Assalamualaikum class. So today the topic that we'll be doing is series, and the first subtopic from the topic of series is binomial expansion. First, let's just understand how do we expand things. If I give you a plus b and it has a power 1, that means you're not supposed to expand it. It is already in expanded form. And I can write it as a plus b just a plus b. What about a plus b whole square? What does this mean? What does a square mean? Square means multiplying by itself. Those who are familiar with the identity can use it, a plus b whole square. Those who are not must know that this means a plus b multiplied by a plus b. Can you expand the bracket, simplify, and let me know? So once you expand and simplify, you get a square plus 2ab plus b square. Is this right? Class? Remember, this topic is the topic of series is more about observations and presence of mind. If you're not good at observing things, if you are not active while looking at the patterns that are right in front of you, if you are unable to observe and use patterns and trends, you will be very weak in this topic. So the primary skill required for this topic is observation and presence of mind. Now, if I ask you the same thing for a plus b cubed, what does cube mean? If I ask you 5 cube, you tell me, how do you calculate it? Very good. Or you can also say that a plus b multiplied by its own square, right? You already know what the square is, right? What is the square? A square plus 2ab plus b square. This entire thing will again multiply by a plus b, right? Expand and simplify and let me know what do you get. See, when I tell you to expand and simplify, then you must add or subtract the like terms, which you people are currently not doing. Now, if you observe carefully, these two are like terms, aren't they? These two are like terms. Can't you just add or subtract them? Okay, so what do you get? A cube plus 3a square b plus 3ab square plus b cube. Right? Remember, we are concerned with the expanded form. That is what we are trying to observe. We are concerned with the expanded form. Okay, now if I ask you the same thing for a plus b to the power 4, what does that mean? A plus b will again multiply by the cube of a plus b, which I already know, right? So in place of the cube, I can just write this. Remember, this is just a one-time drill that we are doing. We'll not always do this. We are just doing that so as to understand the formula that will be provided in the exam. Expand and simplify. So once you expand, you get a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube and plus b to the power 4. If you would have done it carefully without making an error, this is what you would have got. Again, this is just a one-time drill that we are doing in order to understand the entire expansion. Now, what is the trend or the pattern that you observe in this binomial expansion? Again, binomial expansion means two unlike terms, and when there is a power on the entire bracket, we can expand them, and this is the expanded form that we get. So now let's just try to observe and note down the trends. If I'm saying a plus b to the power n, where n is an integer, positive integer, when n is a positive integer, the first thing that you people can tell me is, what are the number of terms? If the power was 2, how many terms did you have in the expansion? 3. When the power was 3, how many terms did you get in the expansion? 4. When the power was 4, how many terms did you get in the expansion? So now we are trying to generalize the entire trend. If the power is n, where n is a positive integer, n plus 1. This is the first thing that we have observed about it, right? So one thing we know for sure, if I give whatever power I give, if it's a positive integer, you'll tell me that the number of terms will be one more than the power. If I give you power 9, how many terms would be there? Not just 10 terms, 10 unlike terms, the terms that can not further add or subtract with each other. Is this right or wrong? While we were expanding, we even got more terms, but once we simplified them, we eventually got 5. When the power was 4, we got 5 unlike terms. I could not add or subtract them further. Is this right or wrong? So, not just terms, all of these are unlike terms. They cannot add or subtract. They won't have the same power of the variables, etc., etc. Is this clear? Okay, the first thing was that we observed was the number of terms. The next thing that is clearly obvious in this, the power of a being the first term. How does it start? When the power was 4, you started with the power a as 4, but what if the power is n? And then what will happen to the power of a? What will happen to the, yes, it will start decreasing. In second last term, a will have a power 1, and in the last term, a will not have any power at all. I'm not written the entire thing. These are just steps that we are taking. And remember, the formula is provided in the paper, so you don't need to worry about the formula. We are just trying to get our heads around the entire expansion and trying to understand the trend. N की power, n की value नहीं पता. Yes, you're right. You don't know the value of n. Obviously, we're just trying to generalize it. Now, n can take any positive integer value, right? Okay, the next thing that we observe is the power of b. B being the second term. The first one has no power of b. The second term has b as the power 1. Then the power of b becomes 2. It keeps on increasing. The second last term has b as the power n minus n. And the last term has power b as n. Is this clear? Is this clear? You started with the power 4, the last term had b to the power 4. If you were expanding power 3, the last term was b cubed. So if you have a power n, the last term will have b to the power n. You can clearly observe it from the 3 expansions that we have just done before. I've just told you that this topic is more about observations, observing the trend, looking at the pattern, extracting a pattern out of things. That is our major objective in this topic. Is this clear? Now, the only thing that remains is the coefficients, right? Now, you will try to make a pattern around it, but Pascal has already done it. There is a Pascal's triangle. I'll try to make the entire triangle. Pascal has already done it. Okay. Now, the first term, I'm just writing down coefficients 1 and 1. The second one, 1, 2, 1, 1, 3, 3, 1. And then it's 1, 4, 6, 4, 1. Okay, these are the ones that we have done, right? Now observe. The first and the last coefficients are 1. Then how do you get 2? You just add the 2 numbers above it, you get 2. How do you get 3? You add the 2 numbers above it. 1 plus 2 is 3, and then again 2 plus 1 again is 3. How do you get 4? 1 plus 3 is 4. 3 plus 3 is 3 plus 1 is, and the last one again is n. If I asked you for the power 5, can you tell me the coefficients for power 5? 1, the first is 1, and then 5, 10. No. 10, 5, and then 1. Observe. Yes, both will be 10 and then 5 and then 1. So if I ask you, just for the sake of understanding, a plus b to the power 5, can you just tell me without going through the entire expansion process? The first term will have a to the power 5. Then you take the coefficient from Pascal's triangle, right? 5. A takes the power 4 and b takes the power 1. Then you take the coefficient from the Pascal's triangle 10. A becomes cube and b is squared. Then again 10, a is squared, b is cubed. and then 5a b 4, and the last one is b to the power 5. But we will not be using Pascal's triangle. This is just something that I'm letting you know. You can use it, but in A levels, we don't focus on Pascal's triangle. Yes, it's something that we should know. We can use it. It's not forbidden, but we have a better, quicker, and a method that is more applicable. Is this clear? The other way to get the coefficients. Now understand this. Currently, we'll just be using them. Once we come to S1, in the topic of permutations and combinations, we'll be covering up the entire reason behind these calculations. Right now, we are just using a particular method, using combinations to get the coefficients. And what is that? I'll be writing it down. I'll just make a matrix and I'll write it down in that particular way, the one that is mentioned in the syllabus, NC1. Write it down. This formula is provided NC2 no, that this one will be n minus 1. The last one will just be NCM, so I'm not writing it down. One thing we already know that the first and the last one do not have any external coefficient. They are just the first term to the power n and the last term to the power n. Okay, now what does this mean? What does this mean? If I'm writing down NCR, this means NCR. This is what it means. Both mean the same thing. So this entire thing can also be written, again, this is the one that is provided in the syllabus, so you must be familiar with this, right? I'm just letting you know how else this could have been written as well. You can write this entire thing in this way, NC1, NC2, and then NC n minus 1. Okay, now let's try to do, and I'll explain how do you do that in the calculator as well. Let's try to do a plus b to the power 5. Now, instead of Pascal's triangle, we'll be using NC1, NC2 to get the coefficients, right? So the first one is a to the power 5. And then I'm writing it down in this particular manner. Obviously, we'll be using it in the calculator in the other way, but the one that is mentioned in the syllabus, I'd prefer that NC1. N is 5 here, so I'm writing 5C1 for the coefficient. It's written in a matrix form, right? A takes the power 4, B takes the power 1. Then what do I get? 5C2. A becomes cube, B is squared. Then I get 5C3. A squared and B cubed. And then I get 5C4. A b to the power, and then it's 5c5, but I know that the coefficient will be 1. I'm not even writing it down. I just know b to the power 5. Is this clear? And now how do we do that? Understand this thing. 5c1. Okay. So 5, then you press a shift, and then there is an NCR right above the division sign, 5C1, and it gives you the value 5. Then you take 5C2, and it gives you the value 10. This is the alternate or the method that we'll be using to get the coefficients rather than using Pascal's triangle. Is this clear?
Yes.
No, that's cos. No, that is just an alphabet C. That's a different thing altogether. This is NCR. This is a specific combination. 5C2, 5 combination 2. We'll be discussing the details of this entire process in S1 permutations and combinations. Right now, we're just using it to get the coefficients. So this is just something that is replacing Pascal's triangle to get the coefficient. The rest of the expansion remains the same. The first term starts with the power n and reduces to power 0. The second term starts with power 0 and reduces and increases to power n. Is this clear? The first one does not have a separate coefficient. Neither does the last one. Is this clear? And now let's try to attempt a few questions. Okay, let's do this one. Find the first three terms in the expansion of 2x minus 3 upon x to the power 5 in descending powers of x. Once we start expanding it, remember the expansion that we did, it was a plus b to the power n. But this one involves a negative sign in the middle, right? Something that is subtracting. So what do? We associate the negative sign with the second term. So now if I ask you what is a in this question, you'll say 2x. And if I ask you what is b in this question, minus 3 upon x. Is this right? And how many terms will this expansion have? 6. But how many are we supposed to write? I'll read the question. How many are we supposed to write? First 3 terms. So let's expand this one. Let me know what do you get. So once you expand it, what do you get? 32x to the power 5 minus 240x cubed plus 720x. Remember, these three values are multiplying. 5c1 will give you the value 5. 2x to the power 4 will give you 16x to the power 4. No, you cannot put 2x in your calculator. You just put 2 to the power 4, which is 16. First, just expand it. If you are having any confusions, just write the expanded forms first. This is no big deal. You can just write 32x to the power 5 plus 5c1 is 5. This is 16x to the power 4. And this is minus 3 upon x. And then 5c2 is 10. 8x cubed. Remember, it is being squared. This is 9 upon x squared. Now you can just multiply and let me know the final value. Remember, these three are multiplying. And when you multiply anything to a fraction, the numerator multiplies with the numerators and the denominator multiplies with the denominator, right? So 5, 16, and minus 3. These are the numbers that you will multiply, right? And for x, you'll have to think a little. X4 in the numerator and 1x in the denominator. So you're left with x cubed. 240x cubed, not just x. Similarly, here's the same thing. 10, 8, and 9 will multiply. Remember, this negative sign is also squared and become positive. So be careful with this. If you have a negative sign, it's squaring, so it will become positive. If it's a cube, it will again become negative. Is this clear? Be careful with the negative sign. Is this clear? Yes. If you're not writing it down, you will miss out on lots of things. So you need to write every step down. Now the question says, hence find the coefficient of x in the expansion of this. Okay, how do I intend to expand it? How should I expand it? If you just tell me to expand, if there is no question associated to the entire thing, and if you tell me to expand, how would I do it? Understand. And again, do not use the answer. That's what I'm saying. If you tell me to expand these two, how do I intend to expand it? I'll first expand the power 5. If I tell you 2 into 3 square, how do you give me the answer? 2 into 3 square. You first square the 3, right? If I tell you 2 into 3 square, what do you do first? You square the 3. This is 9, and then you multiply it by 2. So if I tell you to expand these two and multiply and give me the answer, so what do you do first? First, you expand this power 5. And if you expand this power 5, how many terms does it have? 6. If needed, I'll write more terms, don't worry. Right now, can I write the first 3 terms that I have already expanded for this? And I have written dot, 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 because there are more terms. And if needed, I can, and I will find next terms as well. Okay, And if you tell me to expand these two, first I'll expand this power 5. Whatever answer I get, I'll then multiply it with this bracket and then give you the final answer. Is this right or wrong? And this power 5 means that I'll get 6 unlike terms. Agreed? 3 of those I have already written and I've placed dot dot dot, because if I need any more terms, I can find it, right? Is this clear? Possibility is there. If you need more terms, then you can find it, you can write it down if you need more terms. And now how do I expand it? How do I multiply the two brackets? I'll take 1 and I'll multiply it by the entire bracket. Then I'll take 2 upon x square and I'll multiply it by all the 6 terms. Is this right? This is how it is supposed to expand. Agreed? But I'll only write the terms that I need. Again, I'm not denying the expansion. The expansion exists, but I'll only be writing down the terms that I need. I've constantly told you right from the beginning of this topic is more about presence of mind and observations. So you need to have the presence of mind of what terms do you need. So let's see, if I multiply 1 by 32x to the power 5, do I get x? The question says coefficient of x, that means just x. Do I get just x? No, I get x to the power 5. So I do not need to write it down. Then if I multiply 1 by minus 240x cubed, do I get just x? I'll get x cubed. I do not need to write it. Obviously, it will multiply, it will expand, it exists. I'm not disappearing it. It will be there. I'm just not writing it down because it is not required. Just like in the previous question, there were 6 terms, but how many were asked? So we wrote 3. We did not write the next 3 terms because the question was not asking. We just put a dot, dot, dot. If needed, we can find more. So if I multiply by 720x, do I get just the x? I'll just multiply 1 by 720x and I'll write it down. Again, there were more terms. I'm not denying any of those terms. I'm just not noting them down. Similarly, if I take 2 upon x square and I multiply it by 32x to the power 5, what power of x do I end up with? Take 2 upon x square. Take 2 upon x square and multiply it by 32x to the power 5. You'll end up getting x cubed. Do you need that? Hence, I'm not writing it down. It exists. It is there. But I'm not writing it down. Then I take 2 upon x square and I multiply it by minus 240x cubed. What power of x do I end up with? X as a power 1. Why? Because x cube will be in the numerator. X square will be in the denominator. And I end up getting x as a power 1. So I take 2 upon x square and I multiply it by minus 240x cube. I end up getting minus 480x. I already know that all other terms are unlike. Right or wrong? So I know that no other terms can give me just x except these two. All of them will have different powers of x. None of them will have just x. Is this clear? So if I simplify them, plus 720x minus 480x, I'll end up getting 240x. The question is asking for coefficient of x. So what will be the coefficient of x? Just 240. Is this clear?
Yes.